Great. Well, thank you so much for that introduction, and I'm really excited to be at this talk. Thanks all for who are attending. This is all about Jupyter Notebooks and specifically using notebooks within a team environment. The goal is for this to be a very practical guide. I'm going to be throwing a lot of like tips and tricks and different tools that you could use within your team. So my hope is that you'll find a couple of those that really pique your interest, that are really applicable to your scenario, and then seeing how you can kind of incorporate them into your own practice and into your own team. So I'll cover a lot of things, but the idea is for you to get like one or two good nuggets of information, really about how to kind of streamline the process of utilizing notebooks, how to make it really good working on a team, reducing pain, easy ways to kind of review notebooks and share them amongst each other, and all of that. Really just like a lot of good stuff, a lot of good practices for using notebooks. A bit of a background on me. I'm a senior data scientist at Saturn Cloud. A lot of my work is really focused on making sure that data scientists are operating at their best capacity, whether that is using the latest and greatest tools, making their code run faster, or enabling their teams to do things in a much more streamlined and better way. So you can find me on the internet with a few of these different things, or send a chat to me on the chat platform. Happy to discuss after this talk. So the premise of this is all about Jupyter Notebooks. So here's the Jupyter Notebook that we all know and love. Probably a lot of people are very used to using them. I'm going to assume that most of the people attending this talk are comfortable with doing data science in Python and are comfortable with working inside of Jupyter Notebooks. So I'm going to get a bit philosophical here at this point, and this serves mostly as an outline for what we're going to talk about today. But basically, I'm going to get super philosophical and talk about the fact that a notebook is not only a notebook. There's more that comes along with it. And then we'll get into really more of some of the best practices. A lot of them do come from the software engineering and software development world. So it's really not that philosophical. Mostly, I'm just going to be yelling at you and giving you best practices. So, and at the end, I'll give a demo of Saturn Cloud. It's a platform for doing your data science work in the cloud with a team. And we do a lot of stuff to streamline the notebook experience, and a lot of the pain points that I talk about here, we help solve. But most of the talk will be just general. Here's how you do things with notebooks. You can incorporate any of the tools that you would like. And then if you want, you can see how Saturn Cloud works. And I think it's a really great platform to kind of do your work. So we'll start off first with talking about how a notebook is not only a notebook. And let me kind of start this off with just like a little story, right? So let's say that you write some notebook, pull in some CSV file that you have on your laptop, do a bunch of cool work, generate a bunch of plots, train some models, and then you're really excited about it, so you want to share it with somebody, right? So then you email it or you Slack it to your colleague, but they try to open up that notebook. They go in to run the first cell, and boom, the package that you're using doesn't exist on their computer. Or they might have the package, but they have the wrong version of it, or they have the wrong version of some dependency. And worst case, your code will like fail halfway through the notebook, and they won't really know what's going on. And maybe your data, they don't even have the same data file as you, and so forth. So really what I'm trying to say here is that a notebook contains code, it contains the outputs, and it can contain documentation, right, through markdown cells and such. But there's always some things around it that need to be in place for the notebook to actually run successfully. And that's, yeah, and here are some of the things that you would have to consider when you're thinking about notebooks, right? Like what packages are being used in the notebook. Somebody else doesn't have that package installed, and the exact version sometimes of that package, you might have a bad time, right? How would you access the data? Are you doing any operating system specific stuff? So if you're dealing with files, you might be writing them under like Windows, and then somebody pulls it up on a Mac or a Linux machine, and then those operating system commands don't work. And then sometimes there's things that you might like to set up, like Jupyter extensions or widgets that require some, again, operating system commands just to activate the extension, which might, again, the other person might not have that extension activated. And so you have some commands that you would need to run to actually get the notebook fully working the way that you would want. And so really the way that you ensure this, at least from the Python package perspective, are virtual environments. So if you take away one thing from this talk, you always really want to use a virtual environment. So even if you're just playing around with stuff on your laptop, it's really burned me by using the base Python, and then I install a bunch of packages. I want to upgrade one, but then it breaks the whole installation, and then now my Python is not in a workable state, and then I can't do anything. all that pain is saved by using virtual environments. So there's a couple options here. And again, I'm not going to get into super details, but I'll provide links and I'll provide the slides afterwards as well for everybody, where you can go learn about these yourself. Two really good options are virtual env and conda. They create these text files, which are artifacts that describe your environment. So virtual env, if you do pip freeze, you'll get this requirements.txt, which is a file that'll list all the packages that you have in your environment. You can send that to somebody else. They can create an environment based on those packages and those versions specifically, and then they can run your notebook. Same way with conda. And this works as well if you're doing multiple different things on your own laptop. Let's say you need to run some analysis and pull data from a database, and you need a specific version of, let's say, the Snowflake connector. But then you want to do another project and you need to do some machine learning that requires some different package versions. You can create a new environment and go ahead and then start working on that instead of having to uninstall, downgrade packages, upgrade packages. It can really be a mess, and so, you really sometimes need to be pinning to specific versions on packages. So that's environments. If you stop here and you start using an environment, that means I've done my job, at least for this talk. But there's a lot more, right? And so environments only cover Python dependencies. So they'll cover pandas, and you say, I want pandas version 1.0.1, right? And you can list all of your different versions that you would want. But again, sometimes there's operating system level stuff that you need. One that's always generally a pain point is graph viz, right? If you've ever tried to do some graph visualization, a lot of times you might need to install that at the operating system level, not just with a Python package. And sometimes, like I mentioned before, there's extra commands that you would need to run to set up things, move around files, set up a Jupyter extension that won't really fit in your requirements.txt. Like you could throw them at the top of your notebook and say, run this command, then run this command, then run this command, and somebody might be able to follow along with that. But ideally, you would have some really easy, repeatable, straightforward way to actually share the entire environment, so not just Python, but also the operating system level stuff and any other type of setup. So that's where Docker would come in. So if you're not familiar with Docker, Docker is a virtualization platform for basically the entire operating system. So if you think about it as you can run basically another virtual computer from your computer. So I have a Mac. If I needed to run like a Linux operating system, I could grab a Docker image, and then that image is encapsulated and it's treated like its own computer. It has its own operating system, and then I'm running now Linux commands. So I can install Python there. I can install my Python packages, do my operating system stuff, and then now that's a self-contained box that I can now just send to somebody else, and that box is going to work the same exact way on their computer because it's a virtualized layer of the operating system. So it would run on a Windows machine, it'll run on something in the cloud. That's the main premise of Docker. So that's like a really good way to ensure that if you want to send somebody code and you want it to 100% work, you send them a Docker image, they can pull down the Docker image, and then they can start working on stuff. Again, I'm not going to spend all that much time explaining each of these individual concepts. Here's a link if you really want to learn how to get going with Docker for data science. It's a great tutorial. It'll kind of take you from beginning to end, and then at the end of it, you'll have something set up with like Jupyter Lab and being able to like run and do your work. And I'll admit actually that I haven't really built any Docker images myself. And part of that is because I was a little lazy and a little stubborn, and it definitely has bit me before. But also because at Saturn Cloud, we make it really easy to create images without actually having to do a lot of the Docker behind the scenes work. And again, stay tuned. At the end of the talk, I'll show you how it's really easy to kind of create and configure images in Saturn. Okay, so that's the environment part, right? A notebook is not only a notebook. There's other things that come around it, package versions, setup, and all that stuff. The rest of this, I'm really going to focus on the code of the notebooks themselves. So the first thing is that I want to also reiterate to you that a notebook is code. So a notebook should be treated like any other code artifact. So if you come from a software engineering background, you would understand that this involves style guides, this involves code quality checks, version control, doing code reviews on pull requests and such, right? If you don't come from a software engineering background, those terms might be a little newer to you, but I'll kind of explain what's going on here. The main thing, one of the main things that I would want to get across is that a notebook, again, should be tracked in the same way that you would track any other source code for an application. a lot of the times we can get lazy and create a notebook and say, oh, this is just like a one-time thing. I'm just going to do some quick analysis and then I'll forget about it. But it usually always comes back to you, and we'll talk about that. So as far as like anti-patterns, right? Notebooks, and because notebooks are code, you don't want to do any of these things. So like emailing a notebook to somebody else to expect them to collaborate on it and then email it back to you is not a great pattern, right? You're not able to track the changes. Again, you're not sure if they're running on the same environments, all that kind of stuff. Typically, for source code, you use a version control system like Git. You can use GitHub to kind of manage all of that stuff. I would highly recommend to keep all of your notebooks in a Git repository, especially also because that backs them up to the cloud, right? If you push it, it's now in your main branch in GitHub or whatever other version control system that you use. And it's not being stored on like one person's desktop folder, because if their computer catches on fire or if they're on vacation, now nobody has access to that notebook. That's not a great pattern. And the last thing is something that I'm actually very passionate about, is that any code that's tied to business critical operations should never see the light of day unless at least 2 pairs of eyes look at it. So what I mean by that is, let's say somebody comes to you and say, hey, can we get some report on like how many new customers we've had this month, right? You might spin up a quick notebook, pull some data from the database, create a quick chart, and then email that chart to that person, and then kind of feel like you're done. The problem is maybe you didn't know some exceptions about cleaning the data, or maybe you made a small bug in the way that you visualize the code and kind of changed how the data might be analyzed. Some of that stuff could be saved by somebody else on your team spending 10 minutes looking at your code and making sure it's all good. So I'm definitely a big proponent of peer review and code reviews, and the mechanism of that in a lot of version control systems is through pull requests. So I'm a huge fan of always doing pull requests for all of your code, push it to the main branch, and then you can use that as your source of truth of here's what the kind of real code is, create a branch, work on it, and then kind of merge it back in. So again, back to that story of like somebody asks you for some quick numbers. This is something that I've learned a million times throughout my career, is that there's never a thing as a quick query. There's never a one-time query. You're pretty much always going to come back to it. Like worst case is you're gonna write that query for them, right? They're gonna come back in 2 months and say, hey, can you give me an update on those numbers? You go find, take 10 minutes to go and find that notebook. You try to run it and you realize, oh, I have different versions of all the packages now. The notebook doesn't even work. And then, oh, well, maybe the data changed and I went to go run it and now it's giving me different numbers. And now you have to spend your entire day debugging that and figuring out what went wrong before. Whereas if your notebook was peer reviewed, version controlled, and checked in some of the ways that I'll show you later on in this talk, a lot of that pain can probably be saved. You would be able to go find that notebook immediately, run it, give them back the new answer. So, okay, so here's getting into a little more tools. And again, this is gonna feel a bit of like a laundry list of like me throwing tools at you, but hopefully I can kind of explain to you why they're really important. So it's one thing to be committing your code into a repository, having other people reading it, but there's some actual code level stuff and some basically some policies that you can use to make sure that all of that reviewing is streamlined, and also to make sure that your code is actually up to the highest quality. So there's this tool called Black, which is an auto formatter. And really what's very helpful about this auto formatting is that it'll enforce a similar style across everybody's notebooks. And the reason that that's important is that it makes reviewing diffs in between files a lot easier. Because let's say if we disagree on how to do formatting, I like to use double quotes, but somebody else likes to use single quotes. Every time I edit their code, I'm going to switch their single quotes to double quotes. That's kind of just like a waste of time for people to review. It's better if the formatting is all consistent, and Black is a tool that'll kind of like do that automatically for you. Flake 8 is a linting tool, and if you're not familiar with the term linting, basically what it is, it's a static code analysis. It's not going to run your code, but it's going to sift through the code and find places where maybe the style is messed up, or maybe where some things that actually could go wrong in your code. So like for instance, Python is not strictly typed if you have some issues with that, and it's mostly that it's not a compiled language, right? So like it's gonna get run whenever you wanna run the code. So let's say if you define a variable or if you try to use a variable that doesn't exist, you're not going to catch that until you run your notebook or until you run the script. Flake 8 will actually analyze your code and figure that out for you. And those two tools are mainly for regular Python scripts, but there's this other tool called NBQA that pulls those tools into being compatible with Python notebooks. So you can run this auto formatting, you can run the linting directly on IPyNB files. And so let me show you like a really, really quick example of that. So this is just 2 lines of code really in a notebook, but there's actually a few things wrong with this, right? So the first thing is black, again, which is a code formatter. So it's nothing about the like actual way that your code was running. But if you see here, generally the best Python practice is to put spaces around your equal signs when you're assigning variables. So black will actually catch that, and it'll actually modify it in place for you. So you can actually put automated checks into your repository to where it'll just kind of like format it automatically. So that's where this NBQA black command comes in. It analyzed my notebook and it said, hey, you probably want to change this, and it'll change it for you if you use this mutate command. Flake 8 is really cool because it noticed that I imported this package pandas, but actually it'll analyze the rest of your notebook and realize that, oh, you actually didn't use pandas, so you're wasting time importing that. If somebody else who's running this code doesn't have pandas, you might it might not work, right? So ideally, it's the best thing to remove that. It also determined that I never actually set this variable called oldvar, and it's telling me right here that I'm probably going to have a bad time if I try to run this cell because that variable doesn't exist. So those are little things that it seems really little now, but when you go and try to deploy some code to like a distributed system and it's giving you all these errors, it's really helpful to catch as many things as possible early on. And it's really important to catch things before you send your code to somebody else, because then you're also saving their time debugging something that could have been fixed really quickly. Okay, so just like some really nice principles, I think, is before you commit your notebook into your version control anywhere, there's a few things that you could do. Make sure your code cells run in order. I know that with notebooks, we're prototyping and kind of shifting things around all the time. And that's fine when you're prototyping, but I think it's good to kind of take 5 minutes, step back, clean up your notebook, and then commit it. You want to make sure that all the cells run, right? Because again, when you're rearranging things, maybe it won't all run, or maybe it only ran because you had some variable, but then you deleted the code that created that variable, right? You want to make sure that so the next person after you're running this notebook is going to have a good time. Another really important thing is you probably want to clear your outputs if you're committing notebooks into version control, because the outputs can cause really, really big files if you have images in the outputs, if you have big tables of data, and so on. It just makes it a lot easier to review the code. And then you kind of want to run the tools that I mentioned before. Okay, this is a really cool tool, and I'm starting to run a little short on time, so I won't spend too much time on it. But if you're actually doing a lot of this and you're actually following my recommendations of doing version control for your notebooks and code reviews, this tool called reviewNB is awesome. Like, it brings the regular GitHub diffs into your notebooks, because if you know Python notebooks and if you try to do this before, they're actually JSON files behind the scenes. So here's an example of one PR that we had on our repo, and you notice there's like all this weird stuff, and you don't really see the full context of the cell because at the end of the day, this IPyNB is a notebook, so it's kind of hard to read those differences. But reviewNB is a plugin that'll hook up into your GitHub, and then you can actually view the diffs in a rendered notebook. So it's really nice. You can add comments specifically for the cells. It's an awesome tool. You have to pay after like 3 private repos, but honestly, I think it's well worth the money. Okay, so last thing, and I'm not going to spend, actually, there's a couple things. This one is about a notebook being software. So basically, it's the same principle as before. Is like, if it's code, you should treat it as code. And a lot of the software engineering world would never release code without actually testing it. So you want to build some testing into your notebook environments. And so the one way that we do that here at Saturn, it's going to look different in a lot of places, but basically what we do is we run our notebooks from our main branch on a regular basis. So we run a script that'll convert it into a Python script. We'll make sure the entire thing runs end to end without failing. And then we have some GitHub kind of like continuous integration set up to kind of run that on a scheduled basis. So that way we know that our notebooks are of the highest quality. Okay, and then the last thing is that like this is beyond the code part, but a notebook is information. So you can actually use this to share information with other people, right? And when you're going to that part about sharing notebooks with kind of non-technical audiences, you don't really need to share your code, right? So you don't want to email them an IPyNB file because they're, first of all, not going to know how to open it, and they're not going to know how to read it. They're going to get distracted with all the code. There's a couple of really good tools for actually visualizing your notebooks. One is called Voila, which will actually just let you run a command on the notebook, and it'll create a dashboard immediately from that notebook. Panel is another one that has kind of more customization capabilities with it. And then you can also kind of create your dashboard right from within your notebook and then host up a dashboard. But there's still some questions about like how would you actually host that, because you need some server to run the dashboard all the time. So if you wanted to kind of check out some of this stuff all together, we do have this public repo that we use at Saturn Cloud, which power our examples inside of our product. You can check out this repo, kind of make a branch, make some changes, and then kind of like see how a lot of this kind of code formatting and testing stuff works. All right, so quick into Saturn Cloud. I've only got a couple minutes left, but basically we are a cloud-based platform that's meant to be your place to do data science. So we have a Jupyter server workspace where we'll host up Jupyter Notebooks. We also allow you to kind of scale your work out into parallel computing, as well as deploy dashboards and models and other things. And so we provide a lot of these other things around a notebook that I mentioned. So like you can get access to hardware, you can build images right from the UI. We have an integration with Git and ways for you to kind of share projects and publish dashboards and notebooks and so on. And I am kind of running short on time, so I'm not going to be able to do a live demo of the platform, but you can go right to saturncloud.io. You can check it out for free, and reach out to me too on the chat or through my email or any other way. I can also give you like a quick demo of the platform, but it looks like I've got 1 minute left. Before I end, I want to give a big shout out to the team at Saturn, really, that kind of helped build out this examples repo and a lot of the quality checks that we put into our notebook kind of repo. And so I want to give a huge shout out to James and Ben and Julia, who really built out a lot of that infrastructure. They built out a lot of the testing, as well as Jacqueline and Stephanie, who have built out a lot of the notebooks and the structure for the way that we kind of execute those and kind of our life cycle for how we run these notebooks. But with that, I'm going to thank everybody. I'm just probably about out of time. You can hit me up on Twitter here. Again, message me on the chat if you have any more questions, you want to see a bit more about Saturn. We also do have an event coming up next week. Stephanie is giving a talk with Chintan at AWS, really all about Saturn. There's going to be a live demo of the platform there, so you can definitely check it out. So thank you, everybody.